So starting with the very first thing about organic chemistry. Now the very basic thing is that the word organic refers to the chemistry of carbon compounds. Okay. So I'm going to try and finish the topics that we had left. So it's the chemistry of carbon compounds. Carbon, as you all know, it is a group 4 element, and it makes 4 bonds. It needs 4 electrons, which is why it usually makes 4 bonds. And the reason that it makes 4 bonds makes it a very popular element. Remember, small atoms are very abundant, which means that, small atoms are more stable. They make stable bonds as well because they're smaller, so they're close to each other. So the bonds are stronger. But when an atom makes 4 bonds, you can make complex structures out of it. So it's used to make complex structures. Remember, atoms are building block of matter. So everything that's around you is a bunch of atoms all combined together. Just like you're playing with Lego. Now the piece that makes a lot of bonds, that is the one that's going to make complicated structures. So if an atom just makes 1 bond, it's not going to make a very complicated structure. If an atom makes many bonds, it's going to make a complicated structure. I'll just hold on 1 minute for the azan. So this one. As a structural formulas, now you should know the first thing is you should be actually it's used to make complex structures. What we mean by complex structures is that the most complex structures that are around you are living organisms. So almost every living organism is a carbon compound. Your proteins, carbohydrates, your fat molecules, amino acids, they're all carbon compounds. So carbon is a very good building block for making complex structures because it makes so many bonds. The other atoms, they're not very good at making complex structures because like fluorine, it's in group 7, that only makes one bond. So you can't really make a very complicated structure out of it. Group 6, oxygen, again, it just makes 2 bonds. You can't make a complex. So you need a lot of bonds to make a complex structure. So for example, I'm going to try and draw one structure, which is, I mean, most of the structures around you, complex living organisms, cells, DNA, human beings, animals, plants, they all have enzymes, all sorts of structures. Take the structure of your nail, the structure of your hair, the structure of the molecules that make up your eyeballs, etc., the skin, they're all carbon compounds. And the main backbone is carbon. So carbon is really good at making large, complicated structure. Now remember, whenever you're trying to make or show the structure of a molecule, it's a bunch of atoms that are all bonded to each other. So here is one example of a structural formula. Now, a structural formula tells you the information that which atom is bonded to which atom. But the structural formula has to be correct. For example, you've got this carbon atom. It should be making how many bonds? It's in group 4. It should be making 4 bonds. So you can have a look over here. This carbon over here is making 4 bonds. You got this other carbon atom that is also making 4 bonds. It's sharing 4 electrons. You got this carbon atom. It's also making 4 bonds, 2 with oxygen, 1 with nitrogen, 1 with this other carbon atom. The nitrogen atom is in group 5. It should be making 3 bonds. So you can have a look. It's making 3 bonds. The fluorine atom must be making just 1 bond. So that is making 1 bond, each one of them. The oxygen is supposed to make 2 bonds. So it is making 2 bonds. So is this clear so far?
Yes, sir.
Okay, so the first thing, very basic thing is, I mean, this is the main thing. I mean, most of organic chemistry is just this, drawing the correct. I mean, like if I draw a wrong structure, by just looking at the structure, you should be able to figure out that I've drawn something that is incorrect. So for example, I've drawn this molecule. Now, can you spot what's wrong with this molecule? Like, let's look around the first carbon atom. Is that fine? And also remember, hydrogen is not part of any group, but it only has 1 electron, so it only makes 1 bond. I said, is this correct? The first one. Yes or no?
Yes, I think the first one's fine.
Tiga, what about the second one?
No, sir, because carbon's making 5 bonds.
Tiga, so over here it's making 5 bonds. So what I'm going to do is I'm just going to randomly rub this off because carbon is not supposed to make 5 bonds. As I remember, we're just trying to I mean, at the moment, we just have these small atoms. We're just combining them together randomly. So we're just learning how to draw the correct structures. So that is the idea. You have to learn to spot or draw the correct structures. So now this looks correct. What about this carbon atom? Is this correct? Okay, this one is also making too many bonds. It should be making just 4 bonds. What about this nitrogen atom?
It has to make. So it needs to make another bond.
Yes, it's supposed to make 3 bonds because it's in group 5. So you can think of this as a basket. I've got all these atoms. So I can pick any one and I can put it over here. Like I can pick one from this basket and put a Cl over here. Now it's fine. What about this carbon atom? Again.
So it needs to make a double bond with oxygen.
So you can put a double bond with oxygen because because oxygen wanted to make 2 bonds. So that's also fine. So now the structure looks correct. The fluorine is making 1 bond, the Cl is making 1 bond. Remember one thing that the things that make 1 bond, they're usually terminal atoms. Terminal atoms mean they're always at the ends. Okay, like the H atoms, they only make 1 bond, so they're always at the ends. They're always found in the end. The ones that make more than 1 bond, they're the ones that are usually present in the middle of the molecule. So it doesn't mean, I mean, like for example, over here, oxygen is also a terminal atom, but I mean, that is a possible, but anything that makes 1 bond, that would always be a terminal atom. That can never be in the middle of the chain. So you've got all sorts of random organic molecules. Remember, there are infinite number of organic molecules. Anything that you can think of, like even the human body that has probably, I mean, you can think of it hypothetically, you can call it infinite number of different molecules make up your human body. Like every cell, every enzyme, every small molecule in your body, that's a separate organic molecule. So anything, any random thing that you draw would kind of exist in nature. I mean, there might be some virus, might be some bacteria that would look like this. So let's try another randomly drawn molecule. So this time I'm going to try and draw a cyclic structure. A cyclic structure is the one where, I mean, it's obviously cyclic. It's so they're in a circular arrangement. I've put an oxygen here. I've put so one by one. Is this fine?
G, sir.
See, this one, and I'll also bring the. So this one looks fine. What about this one? This one is also making 4 bonds, right? What about nitrogen over here?
So nitrogen needs another bond.
Okay, so it needs 1 more bond. So let's put an H over here. Okay. What about this carbon atom? How many more bonds?
2.
So let's put 2 hydrogens over here. And let's say I've got all these hydrogen atoms. I'm going to start putting these hydrogen atoms just to complete the bonds. So this carbon, how many more hydrogens with this one?
1 more.
Okay, so there's going to be 1 more. And there's going to be 2 more over here. So that's that probably looks correct now. Now, the very first, very basic thing is when you see an organic molecule, you should be able to spot what's wrong with it. I mean, you should be able to figure out what is wrong with the structure. Like if I'll do just one more example. So this molecule over here, can you tell me what is wrong with this molecule? Like what is wrong with the structure? I've drawn an incorrect structure.
Nitrogen needs another bond.
Okay, so the only problem with the structure is the nitrogen was supposed to make 3 bonds, so it needs another bond. And that's about it. That was the only thing that was wrong with the structure, because carbon over here, it is making 4 bonds, 3 with this, 1 with this. This carbon is also making 4 bonds. Carbon is making 4 bonds. And the terminal atoms are also fine. Oxygen was supposed to make 2 bonds, so that's fine. So the thing was that the only problem that you had over here was with the nitrogen. That's it. So that's the first very basic thing. So just remember, draw any random molecule, and you'll be able to spot. The only thing you should be careful about is to draw the correct structure. Now, the next thing we're going to do is we're going to talk about isomers. Because we are at this, we're trying to draw correct structures. So isomers is going to help us with practice that as well. Now, isomers are molecules having the same molecular formula but different. So, but different structural formulas. So different structural formulas. That means they're arranged, the atoms are arranged differently. Same molecular formula means that they have the same number of atoms. So they have exactly the same number of atoms. But having a different structural formula, that means they have different arrangement of the atoms. So I have the same number of atoms, but a different structural formula. The first thing is, let me just give you a background first about isomers. Why are isomers important? What's so important about them? So the thing is that what happens is, let's say you've got this molecule. Like, let's say somebody discovered coronavirus as a virus, right? The very first information that you get about a certain molecule is, I mean, remember, we are constantly, as human beings, we're constantly dealing with bacteria and viruses, and even in the human body, we are dealing with cancerous cells, etc. So there are all sorts of germs and diseases and something happening, functioning improperly in the human body. So there are all sorts of molecules, and we're always investigating them. So let's say somebody goes in the lab and he sees this molecule over here. Now, the very first information that people usually get about a molecule is they get this information, like how many carbon atoms it's got, how many oxygen atoms it's got, how many hydrogen atoms it's got. So let's say you get this information. That's the first very basic information that you're going to get. So for example, you find a virus, the very first basic information that you're going to get is how many atoms it's got, how many carbon atoms it's got, how many hydrogen atoms it's got, how many oxygen atoms it's got. Then just like solving something, like solving a math equation, you start figuring out, like, you know, that you figure out the first thing, which is how many carbon, hydrogen, and oxygen atom it's got. Now what you're going to try and do is try and figure out, like, what would be the arrangement. So someone would suggest that maybe it's this one, that the two carbon atoms are lined up this way, and the four hydrogens are arranged this way. So is the structure correct? I mean, is there something wrong with this, or is it correct? Oxygen is supposed to make 2 bonds. This oxygen is also making 2 bonds. Carbon is making 4 bonds. This carbon is also making 4 bonds. And all the hydrogen atoms, they're making 1 bond, right? So is this clear? This first formula. Sir. Now, the other thing is that you figured this out, right? But then someone else might state that maybe this is the carbon atoms and the hydrogen atoms are probably arranged in a different way. Like maybe the double bond O is somewhere over here. The H is here. The OH, O and H is here, and the H is over here. So you'll come up with all sorts of arrangements. Like, you know, that there are 2 carbons, 4 hydrogens, and 2 oxygens, right? So you'll start investigating. So maybe this is the correct structure, or maybe it's something like this. Like you got a double bond, carbon atom, and you got an OH. Let's just see if you can find some mistake with my structures. Are my structures correct? Carbon is making 4 bonds. Carbon is making 4 bonds. Oxygen is making 2 bonds. This oxygen is also making 2 bonds. Is this also correct? Carbon is making 4 bonds. This carbon is also making 4 bonds. So people will start speculating about this molecule. Someone else might state, okay, no, this is the correct structure. Then somebody else might state that maybe this is the correct structure. And remember, the combinations are kind of, I mean, they're not endless, but there could be a lot of combinations. Like the atoms could be arranged in many, many different ways. So that's the first thing. Whenever you're doing analytics about organic molecules, because all the time you're dealing with organic chemistry. Organic chemistry is one of the most fundamental branches of chemistry because it deals with living organisms. I mean, all your biology, all your medicine, all your pharmaceutical industry, that's all organic. Things that deal with plants, things that deal with animals, things that deal with human beings, it's all chemistry. Even your food, like most of the food that you eat these days, a lot of the substances, food flavors, etc., they're made in the lab. They are synthesized in the lab. So anything that deals with living organisms, that's kind of organic. So is the idea clear that these are all isomers? They have the same molecular formula, but they've got completely different structures. All of them are different. Like you can always spot the difference. Like, for example, what's the difference between these two? The difference is that over here, the OH groups are, I mean, the OA is bonded to different carbon atoms. Over here, the oxygens are bonded to the same carbon atom, so they are structurally different. I mean, this one is different from all the others. I mean, I can keep on drawing more of them. Like I can think of this one. So this one is, so is this clear? Okay, what are isomers? That they have the same molecular formula, but they have different structural formulas. The arrangement of the atoms, their molecules having different arrangement, but the number of atoms is exactly the same. All of the ones that I've drawn, all of them are structurally correct. Carbon is always making 4 bonds. Carbon is making 4 bonds. Oxygen is making 2 bonds. Oxygen is making 2 bonds. So all of them are correct. They're all structural formulas. Now that's the first thing. Whenever you deal with an organic molecule, that's the first thing you start speculating what the structure could be. Once you know that these are the compounds that are possible compounds, then you start doing further test and analysis. Like if I want to check whether this is the molecule, I'm going to do a certain number of tests on this just to confirm whether this is the molecule or not. And so I can, so if I know what this thing could possibly be, then it would be a lot easier for me to do further steps to identify it. So that is what isomers are. These are all isomers. So all you have to do is you have to take the same number of atoms and you have to think of different arrangement. It's like figuring out a puzzle. You start arranging the pieces in different arrangement just to figure out what could be the actual arrangement. So how do you make isomers? The simple thing is you wouldn't be asked to draw complicated isomers. The very first basic thing is you change the carbon chain. I mean, that could be step one. Like if somebody is going to ask you to draw draw an isomer or something. Just change the carbon chain. For example, if somebody is going to ask me to draw an isomer of this thing, and I've got these hydrogen atoms. So what I can do now is, instead of having the carbon atoms in one straight chain, what I can do is I can have the carbon atoms in a different arrangement, the 5 carbon atoms. I can maybe put this over here. And keep the rest as it is. Double bond over this one will have 3 H's. So that's one way of doing this. You just change or alter the carbon chain. Okay, is this clear? So if the carbon atoms, remember, most molecules are going to have this carbon chain in it, most of them. So you just alter it, just change the way it is arranged. So for example, I'm not going to draw the rest of the molecules. I'm just going to show you how you could do this. Like if you have 5 carbon atoms, what you could do is you can have 4 of them, and there could be 1 branch, just like a tree branch. Or you could have 3 of them with 2 branches. So is this clear?
Yes, sir.
Yeah, that's the first thing that you could do. Remember, both molecules that I've drawn over here, they have exactly the same number of carbon atoms. The only thing I've done is I've just changed the carbon atom arrangement. That's it. What else can I do? Like if I want to make an isomer, the second thing I can do is change the position of a group. It could be the position of a group of atoms or anything. So for example, you can have, like if I take this molecule and let's just copy it here. Now what I'm going to do is I'm going to change the position of this group. It's on the 4th carbon atom. Let's make another molecule. Everything looks exactly the same, except I'm going to put the double bond O right in the middle. And the rest are all hydrogens. Okay, so this is another thing that could be done. So these are the 2 easiest things that you could do. If you want to make an isomer like the way I did, if you want to figure out different arrangements, the first thing is just change the carbon chain. That's it. Like instead of having 5 carbon atoms in a straight line, you could kind of move it around. You can have 4 carbon atoms in a line with 1 carbon as a branch, or you could have 3 carbon atoms in a line and 2 branches. And they are isomers. They have the same molecular formula, They have exactly the same number of atoms, but different arrangement of those atoms. Similarly, you can change the position of a particular group in the molecule. So I'll do a couple of more examples because you won't be asked to draw many isomers. At best, you'll be asked to draw just one or two isomers. So for example, I've got this molecule. Now about this molecule, what can be done is I can do two things with this. I can either change the position of the carbon chain. So let's do it over here. So I can make an isomer, or I can figure out a different arrangement of this molecule by one, changing the position of the carbon chain. So 4 carbon chains, so 4 carbon atoms in a row. I'll have 3 with one carbon atom as a branch, and everything else kind of remains the same. Is this clear?
जी sir.
Or the other thing that I can do is I can keep the carbon chain as it is, except I can change the position of the double bond when I place the double bond. Like it was at the end, now I place it in the middle. Okay, so you either change the chain or you change the position of something in the group, in the molecule. So 2 things I've done over here. And so you can do either of those 2 things. So what we can end this with is try and figure out or learn how to draw correct structures. For each one, make 2 isomers. When I say 2 isomers, I say 2 different arrangements. So make 2 isomers for each. I mean, you can pretty much do anything. I just told you or gave you an idea of how to do this quickly. So that's number 1. And also make 2 isomers for this molecule. So for each one of them, make 2 isomers. I mean, that means they should have the same exact number of atoms, but the arrangement has to be different. Is this clear?
जी sir.
So इसके मुझे ना isomers भेजना just, and remember this thing. Okay, remember to draw the correct structures whenever you कहाँ गया हमारा? Remember this one, which group makes how many bonds, ठीक है? So I'm going to just take a snapshot of this and send it to you, ठीक है? ये कोशिश करो अभी भेज दो अगर. चले ठीक है.
So, sir,
Yes.
when making two isomers for each, does that mean that we can make any arrangement as long as the number of bonds for each atom is correct?
That's one. I mean, it should be a correct molecule. I mean, that's the first basic thing. It has to have the correct number of bonds. The other thing is that it should have exactly the same number of atoms. Like the isomer of this molecule will have exactly 4 carbon atoms. It will have exactly 1 oxygen atom. It's going to have 10 hydrogen atoms. ठीक है? So just sending you the snapshot. ठीक है? Okay then. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz, sir.